So, good morning, everyone. First of all, I would like to thank you, everybody, for taking your time out in this busy schedules. Once again, welcome to this webinar we have for transforming the railway infrastructure with a multi-body system simulation and the finite element analysis. I'm sure most of you are already engaged in a lot of design and development activity for railway industries here. So before we start, let me quickly introduce our organization. I represent WIAS 3D, it's a WIAS corporation. Here, WIAS has a multiple industry experience in different domain, like in the high tech, the CPG, oil and gas, petrochemical, process, nuclear, in fact, including railway as well. So this organization started in the US some time back, and now we have offices in Canada, Mexico, and India as well. So now we are engineering company. Typically, our team consists of highly qualified and experienced people, more than 70 plus people. Most of them are either PhD or a master in different domains like the design, the manufacturing, structural mechanics, fluid mechanics, electromagnetics, optimization, reliability, etc. So we are a Dassault System Platinum partner, which enables us to basically provide you the product solution from Dassault System. So you might be aware about that Dassault System has a different brands, and every brand caters different kind of solution. For example, the CATIA deals with the 3D PLM solution, and we have the Simulia deals with all kinds of simulation software like Abacus, Tosca, FESAFE, EyeSight. We have solution for CFD, electromagnetics, etc., etc. So here in this particular webinar, I'm going to talk more about the simulation, so that typically deals with the Simulia brand of the Dassault System. Apart from providing the product solution, we also have a division for engineering consulting. So in fact, the company started as a consulting company long back, and then we eventually moved to provide the product solution. So here, as a company, we have the different groups and the different division and the capability. So our core capability is in the FEA. So these basically summarizes what kind of capability we have at our end. So we can do the component design, we can do design by analysis, complying API, ASME standards, FEA-based fracture mechanics, optimizations, composite structure analysis, root cause analysis of any failure, vibration analysis, and so on. We have another team that typically focuses on the CFD. So here we have a full-fledged CFD solution capability, like conversion, fluid structure interaction, mixing, separation, heat exchanger, etc., etc. And the new trend that we have in today's world is electromagnetic. So you see around almost everything has the electronic and electrical stuff, so that is exposed to the electromagnetic fields. So we have the team which focuses on the electromagnetic solution as well, wherein you can do a lot of different kinds of simulation, like the antennas. Antenna, you can do EMI, EMC, radiated emission, electromechanical devices, optical component, radars, signals, antennas. So all related to the electromagnetic and signal, you can perform here as well. Let me move to multi-body system simulation for railway industries. So here, as I mentioned, that we are partnered to Dassault System, and Simulia is a brand from the Dassault System which deals with the simulations. So Simulia as a brand has a multiple simulation software. One of them is a SimPack, and that is very, very useful in case of the railway industry. So let me just try to basically explain you what is a SimPack as a tool. So it is a high-end multi-body simulation solution. So SIMPAC is used for simulation of any kind of the mechanical and or mechatronic system wherein you have some kind of mechanism. In the animation, what you can see is the car is there, the wind turbine is there. You can see on the right hand side here you have the train. So wherein you have something in the motion and you have some mechanism. So these kind of system can be analyzed very easily, effective, and very fast. And it can be done even in the 3D, third dimension as well. So these kind of multi-body dynamics or multi-body simulation involves the time integration, the linearization, eigenvalue calculation. So this is basically the equation, solving the equation of motion is the key of these kind of the simulation we have. And within the SIMPAC is kind of the general tool where you can do any kind of mechanism. Wherever you have any mechanism, whether it's a wind turbine, whether it is a gearbox or anything. But within the SIMPAC, we have a special add-on or a tool or the package you can say is called the SIMPAC rail. So as the topic of today is mainly on the rail, so I'm going to present mainly the SIMPAC rail as a solution which can be used in the railway industry for developing and designing the railway components, railway bogies, railway engine, etc. and etc. Okay, so SIMPAC rail is an add-on product to general multi-body system SIMPAC tool, which enables the simulation of any railway vehicles. So it has a very long history. It was joint developed by the German Aerospace Center and the Siemens Transportation in long back in 1993, and then it was commercialized in 1996, and since then for many decades it's been in the industry, and our lots of railway customers are using this tool very happily to develop their products to make sure the qualities and the reliability of these systems are in place. So you may have question, who uses SIMPAC rail? So in fact, everybody in the system of the rail, whether it's the vehicle manufacturers like the Siemens or Alstom or Bombardier or Sadler or Nippon Steel. So we have many customers from the vehicle manufacturers. We have suppliers from the railway flag in Nord-Bremse, and whether operators like the Japan Rail, the Swiss Federal, the railways, and in fact the engineering services and research company who provide services to the railway industries, like Canada, service industries from Canada, Ricardo, and that train. So these are some of the reputed companies who have been using our tool for development of the railway company. And of course academic world is there, have been using for their research area the new methodology we have. Some of the example of the vehicle application of SIMPAC rail. This can be used in variety of the railway vehicles like high-speed intercity locals. It's used in the locomotive. It's used in the light rail and the freights and our special purpose even the mountain trains and the hanging trains and all sort of the vehicle can key development can be done with using our tool. So let's look at sorry, let me just hide this one. Let me hide this. Okay, sorry. Okay, yeah, so there's a small quick poll, so please feel free to answer this poll. So are you using any kind of the simulation technology in your product development process?
So everyone, on your right hand side of the screen you will see one question. Maybe you can just select one the appropriate option. This is kind of an interactive session, so we encourage you to respond to this poll. We'll maybe keep it live for 30 seconds or so and then move on with the presentation. Just have to select the right option and click on submit. Okay, Ravindra, I think we can move ahead.
Okay, perfect. So let's move a little deeper. Let's so SIMPAC rail in the design process. So all this begins with the research, and then move to the first concept study of the rail. And then so it basically moves to the offer phase, wherein the feasibility studies are typically done. In this particular phase, we don't have lots of detail available. Typically what you will have is the track and the speed, maybe the the slant of the track. So based on this one, you do feasibility studies, and then typically you move to the next stage, wherein you do the bogie design and the detailed design, wherein you work with a system, subsystem like the suspension, the air spring, and the track, the wheel profile. So you basically start working in a subsystem and designing, analyzing those stuff, and all these system, subsystem put together will have the full vehicle. And then once you have all these things, the most important part comes into the picture, that is a certification, wherein we try to figure it out whether this complying all standards and the certifications that different geography may have. You may have the different in the US, in the Europe, and the China. So that's where we have the proof of acceptance for customer and authority, and that's where most of the simulation using SIMPAC rail is done. About 80-90% is that's where. So what happens is, to have to basically prove that your design is complying all the requirement as per your regulation, either you have to make a prototype or you have to do the virtual simulation. Building your prototype is, as everybody know, that it takes a lot of time, and it is time consuming as well. Okay, so that's where you can do these kinds of you can do the virtual testing, or you can say the virtual simulation, wherein the SIMPAC rails come into the picture. And then once you have all your system working in a place, so it may happen that over the time, when your vehicle is running, the rail is running, there may be certain claims, certain parts, components may be failing, or maybe certain accident because of, this of course we try to avoid in all the costs, but sometimes it happens. So even the simulation can be used for the running projects, especially to deal with or analyze with the different claims, different failure, and that's the actually part of the ongoing improvement and optimization. So it's used in the two different category. One is for new product development, number one. Number two, to improve your own existing product. Okay. So here in the rail, so what you can do is here in the animation, what you see here, this is basically done and analyzed in the SIMPAC rail, where in the curving force has been estimated how much what is the side force, and what is the vertical forces are coming when you have the vehicle running on the track. So these kind of study you can do very easily and effectively here. And another important type of the analysis that people do for the railway is the critical speed. Here from which speed will a vehicle carry out the lateral oscillation. So every vehicle, based on the track and the geography and the design, so you have the maximum speed limit. Okay, so these are basically determined well before the product development. So these are different specs, and based on that, actually you just start designing your system, and that's where you can basically figure it out that with the existing design, what is your critical speed, and you can keep doing iteration till you achieve your target speed here. And then another type of analysis that could be done is a ride and the comfort. So this is one of the most important, because I mean everybody wants a smooth ride. Okay, you don't want a jerky thing. So how do you basically measure the comfort? So this is the analysis in the rail that you see here, and you have the vehicle running on the track. What you do is you basically monitor the accelerations. Okay, so acceleration is a measure wherein you can kind of monitor, and you can figure it out, or and quantify the ride and comfort of the vehicle. Derailment safety is something that's very quite often, and is one of the essential part of the analysis for the railway. That's how you can do this. Is you have the wheel, you have the track, there's an interaction between them. We get more all those things, how much force is coming in the different directions, that can be captured, that can be shown in the vectorial form. And so it basically tells how far is the vehicle from the derailment at the low speed in the narrow curve. So when it comes to so we have certain animation. Let me get my thing here. Okay, just a minute. I want to run my animation here. Okay, yes. Okay, so I mean, unfortunately this animation is not running, but here on the right hand side, what you can see is you have the rail, and actually it goes and take turns. So there are the switches and the crossing. Those are very essential part of the railway track. And when the train is taking turns, so the forces are not constant. Okay, so it changes the moment it starts turning. The force changes. There's different magnitude, a different contact area, and that need to be analyzed and designed very carefully. And that's what we can include in this impact rate. So we have libraries wherein you can include the switches and the crossings, and you can perform the dynamic analysis, how much forces are coming over there. Another one is the crosswind. So something like this on the left hand side animation that you see here. So how does the train behave under wind gas? So these are the basic kinds of analysis any railway industry need to perform. There are certain extreme scenarios that need to be accounted while developing the product. So what you see here is earthquake analysis with certain frequency to 1 hertz. You see swinging, just moving laterally. This is very important in a country wherein you have the earthquake happening quite often, like Japan. Some of the island countries, these use cases, the load cases are very important and prominent, and that can be done here. And what you do is, in a railway you have a lot of components, the suspension, air spring, and so on and so forth. So these components load can be actually analyzed here. So what you do is in multi-body dynamics or multi-body simulation, you perform this system, your dynamic analysis, and you can figure it out how much forces are coming from the system to the subsystem in the component level, and the detailed analysis and design activity can be carried out as well. And there are certain advanced field applications wherein you have the wheel and rail. So wheels are always in contact with the track. Okay, and there's a huge vertical load, not only vertical load, but you have the lateral load as well. And due to this friction and there's a very high load, the wear and tear is quite common. Okay, so how do you basically account for this one? So these kind of analysis can be done with a impact railway to basically see how is the profile of the wheel over a certain period of time. So that can be really accounted for this one. You can do train and the track interaction. We have seen in some of the animation that when the train is running on the track and how it really behaves in dynamically over the time, that can be easily performed. And you can do here the pantograph overhead line interaction. So what happened, you have the electricity supply, and what we really want is the constant in a physical contact between these components to ensure that yes, the electricity supplies are uninterrupted. So these mechanism, entire mechanism, can be simulated and designed and improved as well. Okay, some specific field application. I mean, these is not from the passenger industry. This is for amusement park actually, wherein you have the roller coaster, but there is a railway at the track. So even this kind of the complicated the track systems, wherein you see it goes up and down, up upside down. So these kind of situation can be very, very easily modeled in our solution. Okay. And what you can also do here is the caging. We call it the caging to protect the passenger here. So the clearance measurement and analysis can also be done to ensure the safety of the passenger is there. Okay. And in fact, there's no limitation what you can model. You can model the wheel alone, you can model wheel and axle, the interaction between the wheel and the track and system, subsystem, spring system. So those subsystem can be actually accounted for during your analysis. A very good thing is we can perform very advanced analysis wherein you have the wheel and the track context is concerned. Okay, so this is called elastic contact. So we start with elastic contact as a basic type of contact analysis. So your reaction forces and the friction, these can be accounted. As you can see, the rail is running on, you have the vertical reaction forces. If it touches on the lateral side, so you have the reaction forces from that side as well. And this is about the contact between the wheels and the track, is especially the elliptical if you're modeling with the elastic contact, but this can be even more advanced in the nature. This could be done in the three-dimensional, two-dimensional, and three-dimensional. What you see here, you have the track, you have the wheel, the interaction between them. So as it takes turns, the contact patches actually changes. And what you can see on the here on the left hand side, top left hand side here, so these patches actually moves, and you can visualize how much the contact pressures are coming on a different system you have. We have much more advanced capability for automated fossilizations, the wheel profile outlines, and we can account for friction, not only the friction but the variable friction coefficient that we can account for. So moving to subsystem side, we can model the detailed coil spring model. So this is a very important part of the suspension system. So you have the complete system with the springs, dampers, and all the air spring and so on. So the effect of these system can be accounted while you're modeling your train with the track and the moving and the interaction between them. So all these things can be done in the 2D and the three-dimensional space. So we can model the straight track, you can model them, with the track, with them, taking turns. You have the crossings, you have the switches. You can have arbitrary the track. What do you see here? This is for the amusement park, so it is really complex. So we can even do that one. So the main purpose here in the SIMPAC rail is to simulate the dynamic behavior, dynamic phenomena, and figure it out, how much force are there, what's the behavior. But in the same process, we can make the track flexible also, so we can make it flexible, meaning you can also get the stresses and strain on these components while the train is running on it. And then we can have a little more advanced analysis So what happens is this multi-body dynamic analysis is done in SIMPAC rail. As far as rail is concerned, when we can also club if you have any FEA tool, dedicated FEA tool to make your track flexible, your switches flexible, and then the crossing flexible, so that you can actually get the forces, the stresses, and the strains, so you can do much more realistic simulation as far as rail is concerned. Okay, so here what we see is that this is, this your rail is going on the bridge, so you can make your bridge flexible, and then you can see how much deformation, of course. Sorry, so this deformation is accelerated for visualization purpose, but you can actually see how is the interaction between the bridge and the rail, how much deformation is coming on the bridge, what is stresses, strain. So you can account for all the things like the tracks, the bridges, the turnout, the crossing, guidance rail, etc., etc. Okay, and then we have the linear discrete element considered in FE model, wherein you can have the linear spring, the rigid coupling, and you have additional non-linear discrete elements can be connected to your flex track files, and you can have all sorts of modeling that you can do. So there's a no limitation in terms of the number of flexible body, meaning you can make n number of system and subsystem flexible, meaning you can see the deformation, the stresses, and the strain. So here what do you see? You have the car body, you have the axle and the wheel and the gears. All those things you can make it flexible and figure it out how much force is coming, what are the stresses coming on it. So the detailed and the comprehensive studies can be really done. Okay, so we have a SIMPAC rail wear simulation. So what you do is you have the car, the track, all the system, and then you may have different load cases. You perform the dynamic analysis, and you can perform the wear calculation as well. So I mean, as your car rail goes over certain mileage, maybe 1,000 kilometers, I mean maybe 100,000 of kilometers, so you can, based on that, you can see what is the wear on the profile, the wheel profile. You can get this wheel profile, how is the wear going on in terms of the mileage. And we have multiple add-ons to the SIMPAC, like we have SIMPAC rail, wherein the railway we have the standard libraries available for all the system and subsystem for the rail. You just pick up and model your system and simulate it, and you can analyze the entire railway. Similarly, we have some other add-ons for SIMPAC, like drivetrain simulation. You can basically have all the gear system. These are readily available libraries. You can build it and customize it and see how things are happening, and you can see this multi-body. And out of it, this SIMPAC rail can be integrated with your FE Safe, meaning what you can do is you can have a submodel or substructure generated from the FE solver like Abacus, ANSYS, and Nastran. We don't restrict to our own, but is a free, is available to connect with other solvers. So you create a substructure from FE Safe and bring those things into SIMPAC rail, and while doing your multi-body dynamic analysis, those would be flexible. You can see the stresses, strain, displacement, and all those kinds of activity can be done here. Okay. And then normally what happens when you're doing the analysis, so you have multiple parameters. Maybe you have 10s and 20s and 50 different parameters based on which the performance of vehicle or rail depends. Now let's say you have 20 different parameters, and then the combination. Okay, so here we have another poll. Do you think simulation can help you solve problems coming into your product development process? Please feel free to take a few seconds to answer this question, so let it make it more interactive before we proceed.
Thank you, Raghvendra. Hello everyone. Just one more poll question on the right hand side of the screen. We request you to select the right option and then click on submit. This will help us to interact with you in a better way and get more information of how you think it will help you or not. So the question is, do you think simulation can help you solve problems coming into your product development process? So we will keep the poll for 10-20 seconds more and then move on with the presentation.
Yeah, sure.
Okay, I think we can move ahead, Raghavendra. Thank you.
Okay, perfect. So, as I was mentioning, in any system, whether it's a rail or any other thing, so there are multiple parameters on which the performance depends on. Now, let's say you have 20 parameters. So these 20 parameters, each parameter may have some range, right? So now, if you want to vary these parameters, so there will be hundreds and thousands of different combinations, right? And our aim would be to basically get the right combination of these values. So manually this will not be really feasible. So that's where you have the design of experiment. Okay, so that's where it can help you to arrive to the right combination for your optimized solution. So that's very much possible to perform the design of experiment here, wherein you can get all the Pareto analysis of the main effect and statistical data analysis you can do here. So this was mainly main of the multi-body dynamics, multi-body system analysis, wherein you have the car, you have the track, you have the contact between them. Your train is moving a certain speed, is taking turn. You can check what is the force coming and vertically, laterally, whether it's derailing or not. You can account for all the system, subsystem, suspension, air spring, and all those things. Okay, so that's basically more of the system level analysis you're trying to do it. But if you want to go much deeper in the development of each and every component, there are a lot of detail analysis you need to do. For example, you need to do strength analysis, you need to do durability analysis, you need to do fracture analysis. So all these kinds of analysis can be done with the Simulia tool that we have. So let me take you through finite element analysis of the railway components. So before moving into this analysis part, let me give a brief overview about Simulia's power portfolio. So Simulia as a brand, we have multiple solutions for structural analysis, for CFD analysis, for electromagnetic analysis. Here I'm talking mainly the structural one, but if you have any requirement, please feel free to contact us. We should be happy to help you in any of these domain. So here the structural one, we have some bundle for the structural analysis we call the power of portfolio. So it comes to 4 different tools. Abacus, this is for finite element analysis. FESAFE, this is for durability, meaning after how long, after how many years, how many months, how many cycle your part will develop crack, is going to fail. So that kind of study FESAFE does. And eyesight is mainly for the process automation, parametric optimization. The Tosca, here what you can see, you have geometry, you can do topology optimization. It removes the material, it makes much lighter, more efficient. So these are the 4 different tools that we have in this power portfolio that comes up. Of course, we have much more different kinds of solution, but this is much more relevant here. Abacus, FESAFE, eyesight, and Tosca together can do much more detailed analysis as far as the structural analysis goes. So Abacus is our flagship product from the Simulia. It's been in the market for more than four decades, and is a de facto standard for finite element analysis, specifically when it involves non-linearity. It involves very high fidelity analysis. So what is known for its robustness. So it's very high, a robust solver. It's very fast and reliable. So what you can see here on the right hand side, animation. This is not from Railway, but I just put it just to convey the idea. So here on the top animation, the right hand side is a simulation and the left hand side is your test. So the simulation and the virtual simulation has the value only if it can capture the physics exactly. Okay, meaning I should be able to rely on the test. So what do you see here? FEA simulation is actually capturing is exactly the same thing what is happening in the reality. So what does it mean? So I can basically do the virtual simulation, which gives a high accuracy, the high fidelity, and based on that I can take a decision. I don't need to really go into the prototyping again and again. Of course, you cannot eliminate 100%, but you can eliminate to very high level, and can save a lot of money and a lot of time. And here in Abaqus we can more account for extensive material models like the metals, the rubber, composite, plastics, ceramic, even for the civil, the concrete, the soil, the mud. So there's no limitation as far as the material modeling is concerned. So we should be able to help you modeling any of the engineering material we have. It is also very well known for the contact modelings. We have the highly robust contact models for analysis, highly accurate and reliable with the general contact capability. If you look at here in the care, there are lots of contacts. Okay, this is highly challenging. In a numerical simulation, these kinds of analysis are highly challenging to account for the interface between the parts, to predict the contact pressure, to predict these kind of stresses very highly difficult, and that's where we are very good at. And here what you see is the material failure. So this is kind of crash. What you can show here is FE simulation. It gives very close correlation with the experimental one. That's what we have been doing here. So I will take you through a couple of the slides where in the component level analysis, the detailed FE analysis have been done by various researchers and our customers. So this performance of the railroad concrete cross ties. So the concrete rail ties have been promising alternative to the timber ties. I think it's no absolute nowadays, I believe so, but in earlier days we used to have timber ties in the majority of the cases. So the concrete is typically used. So you can use Abaqus for analyzing these kind of ties. So here what you show different configurations. So you have the 4x8 and you have the different configuration of your steels here inside the embedded steel rods. So there could be different configuration of this embedded steel. So what you can see is how these different designs are performing, what is the stresses, what is strain, how the stress is configured and distributed among this one, and which design is better than another one. Was crack, there's a possibility of the crack growing, and where it's growing, when it's grows. So these all kinds of possible question can be answered when you do these detailed analysis, and we would be happy to help you guys if you have any such kind of scenario. Another the area wherein a lot of simulation is done is the crash worthiness. What happens is, in unfortunate events, the rails may come together and it may collide with each other, and the system need to be designed in such a way that it saves the life. Okay, so these concepts need to be basically implemented at the beginning, and that's where you can see this complicated structure. There are some couplers at the crash module that you see. So these are especially designed in case of the crash. So energy should be absorbed by these crash modules. And here what we have shown is the crash analysis when two bogies are striking with each other. So this basically involves performing the nonlinear dynamic analysis and accounting for these contacts. So in Abaqus, these kinds of analysis can be done very easily, and you can estimate what's happening. We can see what is happening, what is deformation, what is energy absorption level, what is happening to your crash module, what is happening to your the safety area, whether it will collapse, and how much area is there available after the crash. These all kinds of things can be done virtually. You don't need to go into the prototype again and again, of course. So this once again you're the crash worthiness analysis from one of our the client, the Sadler rail. So on the left hand side what you see is a physical test setup for a full size car rail car body for static testing. So most of the testing that you typically do in your laboratory should be able to perform virtually in Abacus. So it's a complete car model, and you can apply your loads and boundary conditions, and you can see what is stresses coming up. So in this case, it's a coupler compression of 1500 kilonewton load have been applied here. And not only the structural one, but you can also do the optimization. So this slide talks about the optimization of the rail wheels for the thermomechanical loads. So here you have optimization for the railway wheels. So the wheel web geometry has been considered here, and this can be done the axisymmetric analysis, and the optimization analysis have been performed, and load has been applied, and the geometry can move and take there's a shape optimization. The shape can move, and it can basically predict what is the performance, and it can actually give you the right combination to redistribute the stresses to improve the performance. At the same time, it can reduce the mass. So here we're able to reduce the mass by 20%. That is significant in terms of the performance. So another subsystem, yeah, sorry, there's one once again they have the poll. So yeah, maybe please.
Yeah, thank you, Raghavendra. So this is the last poll question for the day. So we request everyone to please submit your answers. The question is, do you want to know more about this simulation and how it can help you in your area of work? So you can just select the right option and then just click on submit. You'll see the poll on the right hand side of the screen. We will just keep it on for 30 seconds maybe, and then we'll go ahead with the presentation. Okay, so 5 seconds more and then we'll close the poll. Yeah. Okay, Raghavendra, I think you can go ahead.
Yes, yeah, thank you, Mary. So here is the braking system. Braking system is a very important part of rail, wherein you have the brake disc and brake shoes. So you have the disc and the shoes, and if you have to stop, so there need to be contact between shoes and the disc, and that's the kinetic energy is converted into the heat energy actually. And these system can be analyzed in Abacus. So what do you see here is the module of the model of the brake, the railway brake. So you can perform the structural analysis, you can perform thermomechanical analysis of this brake, meaning you can predict so when you apply the pressure through the shoe on the rotor, and how will be the pressure, what is the profile of pressure, and how much pressure is coming up, and how much heat is being generated, what is temperature. Even those things can be predicted using Abacus. And last slide but not the least one, I think there are a lot of participants from the steel industry. So steel industry typically makes the infrastructure for the railway. So you have the rail, and these are typically the rolled product, and this it's not very easy. It's very challenging to produce the rolled the straight rail, and to get the right profiling. So in Abacus, you can perform the finite element analysis to simulate this rolling process. It is typically a multi-phase. Here in this case, I showed it a couple of the passes, but it involves the multiple passes, 10, 20, 10, 12, 15 different passes. So these can be exactly simulated here, the manufacturing process. You can see how much force, the roller force are coming there, which will be helped to design your rolling stack. And you can see what is the deformation, the stresses and the strain, and you can even perform the spring back analysis. So once you roll it, there is a spring back, right? So there could be deformation that can be predicted. while rolling, you can also predict what is the temperature. Okay, I mean temperature, thermomechanical analysis, thermal aspect of it. So here what I showed you, the stresses and the plastic strain. So knowing all this thing, help the steel industry to design better and efficient railway track that will help railway industry in the longer run. So with this one, that's all I have for now. So we would open for any questions that you have. I hope it's very it was useful to all of you. And if you have any requirement of simulating or designing the railways and railway components for your multi-body system, your final element analysis for any component assembly, sub-assembly system, feel free to contact us, and we will be happy to help you. Thank you very much for your time.
Thank you, Mr. Banchor. Thank you for the insightful session. Now we will take the questions which we have received. Also, in case there are further questions, the delegates or the attendees can put up the questions in the Q&A box, and the speaker can take it accordingly. So, sir, we have the first question from Mr. H.K. Raghu. How it is compared to NX solutions? What extra feature it would have?
Okay, so to my understanding, I mean, if you're talking about NX, so here we have what I have proposed. The solution is the multifold. Number one is your multi-body dynamic analysis. In a multi-body dynamic analysis, what you do is you model the whole system. If it's in the rail, so you have the rail, the bogie, the subsystem, this your suspension system, your air spring, the contact between the wheels and the track, and how it is changing when you take the turn, the switches and crosses. So all these can be actually accounted here. This is actually analysis wherein you get the forces and the acceleration. And then the second part I mentioned was the final element analysis, wherein you can do the detailed analysis of your parts, assembly system and subsystem to understand whether your component is safe structurally, is safe for even the durability point of view. Sometimes what happens is, let's say, even the track, I mean, subjected to the load that you have, the stresses may be very, very low compared to the yield one. So you may basically assume that it's actually safe, is not going to fail, but that's not true. When rail is going again and again, is basically the time varying load. So fatigue phenomena comes into picture. So the fatigue is very important aspect. Especially when you have the dynamic events like the railway, so most of the parts are undergoing the time varying load. Fatigue is very important. Even these kinds of advanced simulation can be performed with the solution that I have proposed compared to what you're saying.
Sir, we have a follow-up question from Mr. H.K. Raghu. Whether we can calculate the kinematic envelope through Simpac rail? Also, is it mandatory to procure CATIA with Simulia, or it can take data from NX also?
Yeah, so that's a good question. So so with the Simpac or Simpac rail, you can actually integrate or take the CAT system from any other CAT vendors. It's not restricted to the CATIA only. So you can connect to any other CAT system. You can connect other even FES system. So it is open, it's not restricted to Dassault System product.
So we have a question from Miss Elena. Dear all, what about diagnostic non-destructive technologies of wheels and rails?
Yeah, non-destructive. I mean, what here we do is is a virtual testing. Okay, so in a reality, I mean, in a laboratory, what you do is a destructive or non-destructive, two kind of thing, right? So in a destructive, you basically you go in a test laboratory, you have the setup and you do it. It takes a lot of time and the money. So as advent of the technology, people started doing these kind of tests virtually. So you take the geometry from the CAD, maybe CATIA or SolidWorks, etc., etc. You define your system, you're the speed, you're the track and the wheel and all, and you can virtually see what is really happening. In fact, it gives much more insight than your practical test. For example, if you have any test setup, you are trying to basically measure the acceleration, so you will have only few points to put up those gauges, right? You cannot put each and every places. But opposed to this one, when you're doing simulation, you can measure this acceleration each and every point. Okay, so that's practically not possible in your test. So it gives a lot of different advanced options, and it enables you in a different dimension. So that is really helpful, and that's how industry is using this kind of tool.
So we have a question from Mr. Rohit Jha. Does it have capability for VR prediction of wheel? Also, does it support ANSYS Craig Bampton?
So when you talk about this SIMPAC rail, so you can take the substructure from Abacus and ANSYS to perform the flex body dynamic analysis. Okay, so there's no restriction about it. But when you talk about the wear, yes, you can do the wear analysis inside SIMPAC rail. So it accounts for all the forces that you have on the track and the cornering effect and all those things.
We have a question from Mr. Sayam Hussain. I would like to ask that what is the set limit for flexibility in bridge rail design? How can we control on material fatigue?
Yeah. As far as the fatigue goes, okay, fatigue has a two part in it, or a two parameter. Number one, the design and the material. I will put in one bucket, and then the loading. Okay, so it depends on these two aspects of it. Okay, so this fatigue is typically done at the beginning, so you really don't want it to fail after, let's say, 1 year or 2 years or 10 years. The fatigue has to be accounted, and the fatigue analysis can be done with our tool, as I mentioned. So we have Simulia tools called the FE Safe, okay, and then you can account for these fatigue analysis.
We have a question from Mr. Mahesh Pandey. May I request for simulation used in technology and public processing systems via Simulink, and used special radar signal processing for different aspects?
I would be happy to help you in much more detail. So I would require a little more information. So we do have, in the radar systems and all, we do have complete advanced simulation. Of course, I haven't really mentioned much about these kind of signal analysis and all, but yes, we can do a lot of analysis. So Mehul, maybe we can project our contact details. Is here, right? So you can contact us here, Sevak@yscorporation.com. So we would happy to help you with more details would be required.
Sure, and I will share we'll share the presentation slides also, which will have all my contact details, so everyone can get in touch with us.
Yeah, that would be great.
So we have few more questions. Can we take it?
Yes,
Siddharth, please.
So we have a question from Mr. Subodh. What are the input parameters of train data to power supply simulation study?
Okay, what if I understand completely? So you are actually trying to model, you're the powertrain of the railway, right? So we would I would require a little more detail about what exactly you are trying to model that one. But most of the railway stuff, we should be able to account for here.
So we have a couple of more questions.
Yeah, we can take a couple of more and then
From Mr. Kamal Jain, what can be done for inter-car jumper / components, which is used between two train car body?
to train car body. Yeah, I think I would really need more details, so please contact us, and we would be happy to discuss with you separately in a detailed discussion. I would need a little more details in this topic. Yeah,
Sure,
so
sir.
we can take one more and then we can conclude here.
Okay, sir. So, Mr. Harish Joshi would like to ask, analysis been proven in any factual field conditions?
Oh, yeah. So this is very interesting question I would like to answer. So, so when we develop the software, so there is a very rigorous, the testing in terms of the verification. So there's one testing or verification I would say is done when software is actually developed. It's been in many decades the software have in the market. So first step is itself when you code it, so you basically try to capture all the physics in it. So there's one level of verification when you're developing it. Okay, number one. Number two, it goes into the real field. So there are a lot of customers like the Alstom, North Ramsey, Japan Railway. So these are the people, they have been using it, and they themselves do kind of correlation, and that's how it has been induced in the production line. So I would say yes, the verifications or different solar solution are typically done at the company level, and we keep improving, and customers are also using due to the fact that there are good correlation between the test and the actual test.
Sir, there is a follow-up question from Mr. Joshi. What would be the accuracy or repeatability observed in your modeling?
Yeah, so this is almost the same thing, which I just answered.
Sure.
One, very interesting here. Okay, accuracy. So this is a system. Okay, this is a simulation, is a virtual simulation. Okay, so what we are trying to do is we are trying to basically solve the system behavior in terms of the equation. Okay, when we talk about the equation, there is always certain kinds of assumption. So it will be as close as possible, but there will be always kind of accuracy level, maybe to 5, 10%, 15%. So in industry, even a 15% of result is a very, very good the correlation. So this is number one. And the number two is the repeatability. So repeatability in terms of the simulation is almost 100%. Okay, why is 100%? Because if you do the same analysis today and tomorrow, it should give you the same thing. But that's not the case in your test, because in the test there are a lot of variability, even in your test, even in the environment, even in the user who is doing the testing. So that's how when you do in the physical test, you're really not sure that the setup is exactly the same that you did it last time. Okay, even the sample that you take is not the same sample. So there are a lot of repeatability issues that is inherent nature of the physical test, but that is not actually the case when you're doing the simulation. It will give the same thing. It is bound to give the same thing.
Hello.
Yes.
Yes,
So
yes.
we have a last question that from Mr. Ujjwal Sarkar, that is it a product of Dassault Systems?
Oh yes, yeah. So Wires 3D, we are partner of the Dassault system. So we provide product solutions, and we provide even the engineering services, and the solution which I presented is from the Dassault system. Simulia is a brand of Dassault system. Simulia, under Simulia we have all different software for simulations. Simpac for multi-body dynamics. Simpac Rail is a specialized tool within Simpac that is used within railway industry. And Abacus is a part of Simulia brand, and we have many hundred and thousands of customers using worldwide for the product development and making your design cycle shorter.
Thank you, Raghvendra. I think Raghvendra, we missed answering one question from Mr. Raghu, which was like, can we calculate the kinematic envelope through Simpac Rail?
Kinematic envelope. Okay. I think we should be able to do that once, but we will require a little more detail on that once we can get back to you separately on this.
Sure. We'll get in touch with him. Okay. Any more questions are there, Siddharth?
No, sir. We do not have any more questions. The attendees can put any questions if they have. They can mail me or they can mail Mr. Mehul at msevak@viascorp.com. So all further questions can be answered over email.
Yes, we'll definitely be in touch with over email with all the attendees. Sure.
Dear Mr. Banchor, thank you for the insightful session. Hope all the attendees had a great session. Thank you all for joining.
Thank you everybody for your time, and have a good day. Thank you very much.
Thank you everyone.